Alright, here's how you do Lewis structures. First example, let's take water. Water's formula is H2O. We need to find out how many electrons there are. Hydrogen has 1 each, and there's 2 of those. Oxygen has 6 each. 6 plus 2, there's going to be 8 total electrons. Second step, connect them to the central atom. O will go in the middle. We'll attach the H's to each side. Each H brings 1 dot. We'll use the stars for those. Each O brings 6 dots. We use the smiley faces. 1, 2, 3, 4, 5, 6. Now take a look at it. You've shown all the dots on the page. If I make circles around this O, you see a total of 8 electrons, which is an octet. Around this H, there's 1 bond. Around that H, there's 1 bond. So I've shown everything I need. Oxygen has an octet. The hydrogen is happy because it has 1 bond. Check my final answer. I have 2, 4, 6, 8 electrons, and I'm supposed to have 8. Go on to the next one. For methane, we have CH4. C brings 4 electrons. H brings 1 each. That's 4 more. Total of 8 electrons. Put the C in the middle. Attach the 4 H's to it. Each H brings 1 dot. We'll do closed circles this time. Each C brings 4 dots. We'll do open circles. Now they're all on my page. Move them around as needed. But I already have an octet around carbon. There's 8 electrons. I already have a single bond for the H's. Everything's good. We're done. Double check. We have 2, 4, 6, 8 electrons, and I need to have 8. Next, nitrogen. Don't forget about Brinkelhoff. Each N brings 5 dots. There's 2 of them, so I got 10 electrons to show. Connect one N to the other N. The one on the left, I'll use stars for. I need 5 of them, remember. 1, 2, 3, 4, 5. The other end needs 5 also. We'll use smiley faces for that one. So if I look at this, around this end, you see there's 6. Around this end, there's 6. Neither one has an octet, so I'm going to have to move more into the middle where they're sharing. So I'll take, say, 1 electron from this end, 1 from that end, make a double bond. 1 electron from this end, 1 from that end, make a triple bond. Now you can see around the N on the left, there's 2, 4, 6, 8 electrons. The one on the right has 2, 4, 6, 8 electrons. They have 6 that they're sharing. And count up, make sure there's 10 shown at the end. 2, 4, 6, 8, 10. Move on to the next one. Carbon dioxide. CO2, carbon brings 4 each, oxygen brings 6 each. 6 times 2 is 12. It's going to have 16 dots. Connect the C to the O. C will do closed dots. 1, 2, 3, 4. O will bring open dots. 1, 2, 3, 4, 5, 6. Same thing over here. Move them around now till everything has an octet. You see right now this carbon has 2, 4, 6 around it. This oxygen has 2, 4, 6, 7. This oxygen has 2, 4, 6, 7. So let's say that you take one off this C. We'll take both of them off. We'll put one of them on this O, one of them on that O. Now both O's are good with an octet, but the C doesn't have enough. So you're going to have to end up taking 2 off one of the oxygens and moving in here and making a double bond. And we're done. If you want to draw the circles to double check, you can do that. Around that O, there's 8 electrons. Around that C, there's 8. And around that O, there's 8. Double check when you're finished. You have 2, 4, 6, 8, 10, 12, 14, 16 electrons. And we actually need to take 2 more off this O here and move them into the middle. So now everything has an octet. And now we're good. Okay, continue on. Ammonium, NH4, N brings 5 dots, H brings 1 each, that's 4, so that's 9. Since it's a +1 charge, you got to take away 1 electron, so 9 minus 1 is 8 dots. Put the N here, connect the 4 H's to it. Each N brings 5 dots. 1, 2, 3, 4, 5. Each H brings 1 dot. 1, 1, 1, 1. And now take a look at it. You'll notice that N has 1 too many electrons, so just erase it off of there. We could get rid of 1 anyways because the charge on ammonium is NH4 plus 1. Put it in brackets when you're done. Put the charge outside, and we're finished. One more. Do nitrate. So we have NO3 minus 1. N brings 5 dots. H brings 6 each. 6 times 3 is 18. That gives me 23 dots. Since there's a minus 1 right here, we gotta add 1 more to it. 23 plus 1 is 24 dots. Put the N in the middle. Connect the 3 O's to it. Put the dots in. N brings 5 dots. 1, 2, 3, 4, 5. Each O brings 6 dots. 1, 2, and so on. Keep them in pairs so you can see them. And you can quickly notice that this O has 1 that's by itself, doesn't have enough. Same thing for the bottom O. When I put 6 dots around it, you see that there's 1 by itself. So that tells you that does not have an octet either, the one on the right. And then the last O needs 6 electrons as well. Now, since it's a minus 1 charge right here, that means I can add 1 extra electron wherever I like. So let's take it and we'll put it on this O. So now this O has an octet. The N has an octet. The other 2 O's do not. So how about I take an electron from this O and move it up here. Now this O here has an octet. This N excuse me, this N has an octet. This O has an octet. This O is too short. So you can take the 2 stars and instead of keeping them on the N, you can put them down here for a double bond. So they'll still count for that N, but now they can count for that O also. You want to do one more time where we circle everything in. Around this O, see there's 8 electrons in there, octet. Around this N, there's 8 electrons. This O has 8 electrons, and that O has 8 electrons. And a total of 24 dots should be on the page. 1, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Let's go back and check the geometries for each of those that we've drawn so far. The central atom for this one is the O, and there's 2 things attached to it. There's 2 unshared pairs. That geometry would be that. Next one, the central atom is carbon. Right here, there's 4 things attached to it. There's no unshared pairs on the C. That would be tetrahedral. Next, there's only 2 atoms, so no matter what, if there's only 2, the only possible geometry would be linear. You don't need your chart for that one. This one, same thing. Oh, actually this one, the carbon is the central atom. And there are 2 things attached to it. Doesn't matter if there's double bonds, there's just 2 things, an oxygen and an oxygen. There's no unshared pairs on the C. An unshared pair or lone pair would be like the dots. So there's none of those on the C. So 2 attached, 0 unshared pair. Your chart would tell you that that would be linear. This one, central atom is N. There's 4 things attached. No unshared pairs on the N. on the end, so that would be tetrahedral. And for this one, there are 3 atoms attached, and then no unshared pairs on the end, so that would be called trigonal planar. And there you go.